Welcome back to Java Internals Crashcasts. I'm your host Sheila, and today we're continuing our exploration of atomic variables in Java's concurrent utilities. We're joined, as always, by our expert, Victor. Victor, are you ready to dive into atomic reference?
Absolutely, Sheila. I'm excited to discuss this powerful tool in Java's concurrency toolkit.
Great. Before we start, let's remind our listeners that we've already covered atomic integer, atomic long, and atomic boolean in our previous episode. Today, we're taking it up a notch with atomic reference. But first, let's start with a quiz question for our listeners. Here it is. In a multi-threaded environment, why might you choose to use an atomic reference over a synchronized method when updating an object reference?
That's an excellent question, Sheila. It really gets to the heart of why atomic reference exists. Listeners, take a moment to think about it. Consider the performance implications and the level of control each approach offers. We'll reveal the answer at the end of the episode.
Now, Victor, could you start by explaining what exactly an atomic reference is?
Certainly, Sheila. An atomic reference is a special kind of variable in Java that holds an object reference. What makes it special is that it can be safely read and written by multiple threads at the same time, without the need for explicit synchronization.
I see. So it's like the atomic versions of simple types we discussed earlier, but for object references.
Exactly. Just like atomic integer provides thread-safe operations for integer values, atomic reference does the same for object references. It's part of Java's toolkit for building efficient multi-threaded programs.
That's interesting. Can you give us an analogy to help visualize how atomic reference works?
Sure, think of atomic reference as a lockable display case in a museum. Only one person can change the object inside at a time, but many people can look at it simultaneously. The case ensures that when someone is replacing the object, no one else can interfere, but it doesn't prevent others from viewing it.
That's a helpful analogy. Thanks. Now, how does atomic reference compare to using synchronized methods?
Great question. While both ensure thread safety, atomic reference often provides better performance, especially when many threads are involved. Synchronized methods lock the entire object, whereas atomic reference only locks the specific reference you're working with. This finer level of control can lead to less waiting and better efficiency in multi-threaded environments.
I think I understand. So, atomic reference is more precise in what it controls. Can you walk us through some of its key methods?
Certainly. The main methods of atomic reference are 1. Get, which returns the current value, 2. Set, which changes the value, 3. Compare and set, which changes the value only if it matches what we expect, and 4. Get and set, which changes the value and tells us what the old value was. These methods allow you to perform thread-safe operations on the reference.
That's helpful. I'm particularly intrigued by the compare and set method. How does that work in practice?
The compare and set method is really powerful. It lets you update the reference only if it currently holds a specific value. This is crucial for implementing efficient, thread-safe algorithms. For example, you might use it when you want to update a shared configuration object, only if it hasn't been changed by another thread.
I see. Can you give us a real-world example of where atomic reference might be used?
Certainly. One common use case is in caching systems. Imagine you have a cache that stores the result of a time-consuming calculation. You want to update this cache periodically, but you don't want multiple threads to perform the same calculation at the same time. Atomic reference can help here by ensuring that only one thread updates the cache, even if multiple threads try to access it simultaneously.
That's a great example, Victor. Now, are there any common pitfalls or best practices we should be aware of when using atomic reference?
Absolutely, Sheila. One common mistake is assuming that because you're using atomic reference, all operations on the referenced object are automatically thread-safe. Remember, atomic reference only makes the reference itself thread-safe, not the object it points to. As for best practices, it's important to use atomic reference when you need fine-grained control over concurrent operations. If you find yourself using multiple atomic operations in sequence, it might be better to use traditional synchronization instead.
That's valuable advice, Victor. Now, as we're nearing the end of our episode, could you share an interesting fact about atomic reference?
Sure, here's an interesting tidbit. Atomic reference uses a clever technique called compare and swap under the hood. This is a special instruction provided by most modern computer processors. It's what allows atomic reference to achieve its efficient, high-performance characteristics.
That's fascinating. Now, let's reveal the answer to our quiz question. Victor, would you like to do the honors?
Certainly. The question was, in a multi-threaded environment, why might you choose to use an atomic reference over a synchronized method when updating an object reference? The answer is that atomic reference often provides better performance and efficiency than synchronized methods, especially when many threads are involved. It allows for more precise control, as it only locks the specific reference you're working with, rather than the entire object or method. This can lead to less waiting and better overall performance in multi-threaded scenarios.
Excellent explanation, Victor. To summarize today's episode, 1. Atomic reference provides thread-safe operations for object references. 2. It offers better performance and efficiency compared to synchronized methods in many scenarios. 3. Key methods include get, set, compare and set, and get and set. 4. It's useful in scenarios like caching systems where precise concurrency control is needed. 5. Remember, atomic reference makes the reference thread-safe, not the object it points to. In our next episode, we'll be discussing atomic integer array and atomic long array, exploring how atomic operations work with arrays. Don't forget to subscribe to Java Internals Crashcasts and leave us a rating if you're enjoying the series. Until next time, happy coding!